Now here's a function that's not a polynomial function. This is what we call a rational function because it's written in the form of a fraction. Rational functions, like the first one, and radical functions like the second one, we have to be really careful about our domain. Because when we have a fraction, we have to avoid having a 0 in the denominator. So to find the domain of a rational function, you want to include everything, include all x values, except values that make the denominator 0. So what we do here is we set the denominator equal to 0 and we solve it. Well, this is a quadratic equation because it has x squared in it that I can factor. It factors into a difference of squares, x plus 2 times x minus 2. Then I set each factor equal to 0. X plus 2 equals 0, and x minus 2 equals 0. So that's going to give me, when I subtract 2 here, I'll get a negative 2. When I add 2 here, I get a positive 2. I kind of ran out of room. So these values are what I call the bad numbers. Those are the numbers that make the denominator 0. So here my domain is going to be everything except x equal to negative 2 and positive 2. So I would say x cannot equal negative 2 or positive 2. This example has a square root in it. And remember, here we want to avoid a negative number under the radical because we can't take the square roots of a negative number. So to avoid it being negative, we want to force it to be positive. So we're going to take whatever's under the radical and set it greater than or equal to 0. So then we solve that. So we'll add 6 to both sides. 3x is greater than or equal to 6. Then divide by 3 to get, for our domain here, x is greater than or equal to 2. One more look at the domain. Here we're going to look at a graph. To find our domain here, we want to look at everywhere that we have a graph. So our graph starts right here, and then it goes down, up, and back down over here. So it ends here, and it starts here. So between those points, my graph covers every x value between those points. So the x value here where it starts is a negative 8. The x value where it ends is a positive 18. So here my domain is everything between a negative 8 and a positive 13. So x is between negative 8 and positive 13. To look at our range on our graph, we want to change directions here and look at our y's. So where do I have y values here? I have, this looks like a pretty low y, but this one's just a little bit lower. The lowest y I have is a negative 13. So my range would start at negative 13. And then it's going to go up to the highest point I have is right here, which has a y value of 10. Now, I also can use my graph to find function values. If I want to find what f of 4 is, I go to my graph where x is 4, 1, 2, 3, 4, and see that the point on my graph has a y coordinate of 10. So f of 4 is 10.